Welcome to today's data analysis course. I am Robert Emmanuel, and today we are diving into the foundational skills you will need to become a proficient data analyst. In this module, we'll cover data types, data structures, and some basic statistics. These concepts are crucial because everything in data analysis starts with understanding the data you are working with, whether you are cleaning, analyzing, or visualizing data. Knowing how data is structured and what each type represents will be the key to unlocking your data insights. Now, let's dive into our first topic, understanding data types. Before we go into understanding data types, first, what do you understand by data? Data refers to a collection of information in a raw and unorganized form, which can be processed, analyzed, and interpreted to extract valuable insights, patterns, or meaning. Data can take many forms, including numbers, which are quantitative data, such as temperature, prices, scores. Data can take another form of text. Those are qualitative data, such as words, phrase, or sentences. Another form data can take images, visual data such as pictures, diagrams, and videos. Another forms of data are sounds, audio data, like music, like voice recording, like sound effects. Another form is observations, recorded observations, such as surveys, response, sensor reading, experimental results, interviews, unstructured data. But let me talk a little on structured data. Structured data are organized and formatted data, such as table, the spreadsheet, or databases. Unstructured data are unorganized and unformatted data, such as emails, social media posts, or text documents. And we also have semi-structured data. These are a combination of structured and unstructured data, such as JSON data, XML files. Data is the foundation of information and knowledge, and it plays a critical role in various fields, including business, science, healthcare, finances, government. When you talk of government, you talk about the census, the economic indicator, the policy analysis. When you talk about the healthcare sector, you talk about the patient's record, you talk about medical research, we talk about disease surveillance. When you talk about science, experimental data, research findings, statistical analysis, business, data-driven decision, market research, and customer analysis. In summary, no, data is a collection of information that can be processed, analyzed, and interpreted to extract valuable insights and meaning. Understanding data types. Now, when we talk about data types, we are referring to different kinds of data values that we might encounter during analysis. The primary types we need to focus more on are the numeric and the categorical data. What are numeric data types, or what are quantitative data types? Numeric data, also known as quantitative data, is a type of data that can be expressed in numerical form. It represents quantities or measurements that can be expressed using numbers. And they have some characteristics. One, they are quantifiable, they are continuous, and they are discrete. Quantifiable in the sense that numeric data can be measured and they can be counted. They are continuous, meaning numeric data can take any value within a given range. They are discrete, meaning numeric data can also be discrete. It can take only specific values. Now, what are discrete numbers? These are countable numbers. For example, the number of a student in a classroom or the number of products sold. Then continuous data. This can take any value within a range. Think about height, think about weight, think about time. These are numbers that are measurable and can have decimals. Example, the height, I'm 5.8 feet tall. Now, we've been able to understand that numeric data allows us to perform mathematical operations. For example, you can compute averages, sums, and other statistical measures. It's crucial for any sort of quantitative analysis. Now we jump into categorical data. Categorical data, also known as qualitative data. These are variables that represent categories or group. They are often divided into two main types, the nominal data and the ordinal data. What are nominal data? These data represent categories with no inherent order. Think of things like color, gender, brand names. You can't rank this. You can't rank brand names. You can't rank gender. You can't rank colors. Red, blue, green. You can't rank them. Now, ordinal data. These are data that has categories that can be ordered. For instance, in survey ratings or levels of education or categories, they have a specific ranking. Example, in a survey, you see poor, fair, good, excellent. Those are ordinal data. Now, let's go to the second point, understanding the importance of data types. What do we mean by this? Why does understanding data types matter? Well, knowing the data types helps to determine the right analytical approach. You would not calculate the average of color or perform a sum of gender. You need to choose the correct statistical method based on this data type. Now, let's go to our next section, data structures. Now, we've covered the types of data. Let's talk about data structures. What are data structures? This refers to how data is organized and stored in your data set. For example, we have tabular data. These are data frames or spreadsheets. The most common structure you ever encounter is a tabular data. Think of a spreadsheet in an Excel. Think of a database. These data, they are organized in rows and columns, where each row represents an individual observation and each column represents a variable. If you are familiar with spreadsheets, you understand what I'm talking about. Now, for example, in a sales data set, rows could represent individual transactions. Columns could represent things like transaction ID, date, amount, customer ID, and the rest. Now we'll talk about arrays. We are talking about data structures, and that data structure type is arrays and lists. These are one-dimensional structures where data is stored in a sequence. Array and list are ideal for storing ordered data or when you need to reference elements by their index. You can reference each number by its index, which makes array a powerful tool when working with ordered data. Now, next up, matrix and multidimensional arrays. We have matrix or multidimensional arrays. These are essentially data structures with more than one dimension, and they are useful when you need to represent more complex relationships between variables. For instance, an image is often represented as a 2D matrix where the rows and columns represent pixels value. Now, data frames in Panda. If you are working with Python, the pandas library provides a powerful structure called a data frame, which is essentially a table-like structure with labeled axes, rows, and columns. Data frames are ideal for storing and manipulating data. In pandas, you can easily perform operations like filtering, grouping, and aggregating your data. Now, let's dive into some basic statistics. This is where the fun actually begins because we start to extract insights from the data. The three key measures in statistics are central tendency, dispersion, and relationship between variables. Now let's look at measures of central tendency. We'll talk about the mean. What is a mean? The mean, also known as the arithmetic mean or average, is a measure of central tendency that represents the average value of a set of numbers. It is calculated by summing up all the values in the dataset and dividing by the total number of values. Formula is just mean is equals to sum of all values divided by total number of values. Example, suppose we have the following set of numbers 2, 4, 6, 8, 10. The mean is 2 plus 4 plus 6 plus 8 plus 10 divided by 5. So mean is 30 divided by 5, which is 6. Now, the sum of all values divided by the number of values is the mean, and it's useful but sometimes it can be affected by outliers. What are outliers? An outlier is a value that is significantly different from the other values in the dataset. Outliers can affect the mean in several ways. One, skewed means. If an outlier is extremely high or low, it can pull the mean in that direction, making it less representative of the typical value. Increase variability. Outlier can increase the variability of the data, making the mean less reliable. 3. Masking pattern. Outlier can mask underlying patterns or relationship in the data, making it harder to interpret the mean. We'll give an example of an outlier in the practical session. Imagine we have 2, 4, 6, 8, and 100, and we are to find this mean. Remember, the total number of value there is 5. Sum of all this number is 120 divided by 5 is 24. In this example, the outlier 100 has significantly skewed the mean, making it less representative of the typical value. To mitigate the effect of outlier on the mean, you can use alternative measure or of central tendencies such as the median, the mode, or use data transformation techniques such as framing. Let's talk about the median. This is the middle value when the data is sorted. The median is less affected by outliers. The median is a measure of central tendency that represents the middle value of a data set when it's sorted in ascending or descending order. If the dataset has an even number of values, the median is the average of the two middle values. Suppose we have the following dataset 2, 4, 6, 8, 10. Sorted in ascending order, the middle value is 6. Therefore, the median is 6. Now the mode. The mode is a measure of central tendency that represents the most frequently occurring value in a dataset. A dataset can have multiple modes if there are multiple values that occur within the same frequency. Example, suppose we have the following dataset 2, 4, 4, 6, 4, 8. The value of 4 occurs most frequently 3 times. Therefore, the mode is 4. Key difference between the mode, the median, and the mean. Median is calculated by finding the middle value, while mode is calculated by finding the most frequently occurring value. Median is unique, while mode can be non-unique. Median is less sensitive to outlier than mean, while mode is not affected by outlier. Now, let's look at measures of dispersion. Now, we have range. The range is a measure of dispersion that represents the difference between the largest and the smallest value in a dataset. Now, the standard deviation. The standard deviation is a measure of dispersion that represents the square root of the variance. The standard deviation represents the average distance between each value and the mean. Key points to note: range is sensitive to outliers, while variance and standard deviation are less sensitive to outliers. Variance and standard deviation are related, with standard deviation being the square root of variance. Standard deviation is a more interpretable measure of dispersion than variance. Now, let's move on to correlation and relationship between variables. Correlation and relationship between variables are fundamental concepts in statistics and data analysis. Types of correlation. We have the positive correlation, we have the negative correlation, and we have the no correlation. Positive correlation. As one variable increases, the other variable also tends to increase. Negative correlation. As one variable increases, the other variable tends to decrease. No correlation. This is no apparent relationship between the variables. The correlation coefficient measures the strength and direction of a linear relationship between two variables. Now, interpreting correlation coefficients. One, we talk about strength. Value close to 1 or -1 in a negative one indicate a strong correlation. Meanwhile, when we talk about direction, positive value indicates a positive correlation. Negative values indicate negative correlation. Now, note common pitfall in correlation. 1. Correlation does not imply causation. Correlated variable may not have a causal relationship. 2. Omitted variable bias. Failing to account for relevant variables can lead to incorrect conclusions. 3. Data quality issues. Poor data quality can lead to incorrect or misleading correlations. Best practices. 1. visualize data. Use scatter plots and other visualization to explore relationship. 2. Check assumptions. Verify that data meets assumptions of correlation analysis. 3. Consider multiple variables. Account for relevant variable to avoid omitted variable bias. 4. Interpret results cautiously. Avoid overinterpreting correlation and consider alternative explanation. Now let's wrap up. This brings us to the end of our first module on foundational skill in data analysis. You now have a solid understanding of data types, data structure, and basic statistics. These concepts will be the building blocks as we move to more advanced topics in the future modules. Thanks for watching and stay tuned for next section. Please like and subscribe to my channel. Thank you very much.